Geometry Common Core, the June 2016 Regents exam, starting on number 13. In triangle RST shown below, altitude SU is drawn to RT at U. If SU is H, UT is 12, and RT, this whole thing, is 42. Which value of H will make triangle RST a right triangle with angle RST as the right angle? So this picture probably looks familiar to, what's going to make this a right triangle. We already know this is perpendicular because that's an altitude. It's always perpendicular. What will make this a right triangle, this has to do with the geometric mean concepts, that if I just deviate for a second, that when we do have a right triangle and an altitude drawn from the right angle to the hypotenuse like this, we end up with three similar right triangles. And as a consequence of that, we end up with a couple of special common formulas. I'm just going to clone this and do it twice to show you one thing here. And one of the versions of this, there's two versions. There's the altitude squared formula or the leg squared formula. First, for the leg squared formula, leg squared is part times whole. That's a multiplication dot there if you want to do part times whole. And what we mean by that is if I have a leg, like let me say that this is a leg of 4. As I'm trying to make these numbers up off the top of my head. Let me do this side actually. Let's say this leg is 4, this is 2, and that would make this whole thing 8. Because the leg squared, which is this 4 squared is 16, equals the part of the big hypotenuse that's attached to it, this 2, times the whole hypotenuse 8. So it's 4 squared equals 2 times 8. 4 squared equals 2 times 8 is 16. Now typically what you have is one of these numbers is missing, and that's what you're trying to solve for. It's the same thing on the other side, that if you had the other leg squared, is the other part attached to it times the whole thing. So it works on both sides. The other formula, which is the one we're using here that involves the altitude, is the altitude squared is part times part. So for example, if this is 4, the altitude squared, these are the two parts of that make up the whole thing. This would be 2 and this would be 8. Now 4 squared is 2 times 8. And that's what we're looking at here. Now they tell you that this whole thing is 42, this is 12. That means that this has to be 30. Now what they're saying is for this to be a right triangle, for these formulas to work, the altitude squared, which in this case is your h, would have to equal the product of the two parts down here. And that would be the 30 and the 12. So 30 times 12. So h squared equals 30 times 12. And let's see what 30 times 12 is. $360. And so h squared equals 360. And if we then want to solve for h, the way we're going to do that, of course, is square root. So h equals the square root of 360. And you look at these answers, all right, looks like we're doing simplifying the radical. We need two numbers that multiply to 360. One of them has to be a square number. In this case, it's going to be 36 and 10. And that's because 36 is a square, because it comes from something times itself. Specifically, square root of 36 is 6. 10 is not a square, so it stays inside. 6 rad 10 is our answer. This comes up every test, one of these two formulas, so you really need to be prepared for that. Number 14. In the diagram below, triangle ABC has vertices ABC, as shown here, those numbers. What is the slope of the altitude drawn from A to BC? So from A to BC. Now what's tough here is we don't know exactly where that would intersect. Like, will it cross at this spot? Will it be over here? Where it's kind of, they specifically drew this image so that you couldn't just like pick a spot. But kind of what I just said in this last question here, that I knew this was a right angle because it was an altitude. And altitude is always perpendicular to the opposite side. So I'm not sure where my altitude is going to go, but I do know it's perpendicular to BC. And BC, I know the points for. And I can find the slope of BC. So the slope of BC, I mean, I can see it here on the graph. Looks like it's up 2 over 2, 4, 5. Looks like 2 over 5, but let me do it algebraically too. Again, here comes that very commonly used, super important slope formula. Again, it just means subtract the y's on top, subtract the x's. So the second number in each pair, that's your y's. Subtract your y's, 3 minus 1. Subtract your x's, 7 minus 2. 3 minus 1 is 2, 7 minus 2 is 5. And that's kind of what I guessed, up 2 over 5. So the slope of BC is up 2 over 5. This altitude is going to be perpendicular to that. And perpendicular to 2 over 5 is going to be negative because we switched the sign. This whole thing's positive, so the whole thing negative, and reciprocal. Opposite sign reciprocal. Negative 5 over 2. Choice D. You know, this is just this right here, just a quick word. Like, this is a great example of what the Common Core geometry is all about. You know, they're not just going to give it to you where, oh, it's going to fall here. What's that slope? You got to think about what is an altitude? How is it related to what you have? Oh, it's perpendicular to the side. I could find that slope. So then I could find the slope of the altitude. You know, you kind of have to go the backdoor route of you thinking about what you have, how it's related, what you're looking for, special properties, you know, and you know, figure it out. That's what's tough about geometry. It's always a puzzle. So what is this? This is 14. So let's go to 15. In the triagram, in the diagram below, these triangles are similar. This little triangle, this little triangle. Which statement is always true? And you see a bunch of trig functions here. Now, cosine J, if you look at this angle, cosine would be Jm over Jt. That's not that. And if you look at tangent T, opposite over adjacent, that's not that either. And then you look at cosine R, that's adjacent over hypotenuse, Rm over, that's not it. And if you look at tangent E, that's opposite over adjacent, Rm over, that's not it either. So at a quick glance, you might think these are all wrong. Well, the issue is when triangles are similar, that means the ratios of corresponding congruent angles are congruent, meaning cosine J here is, you know, Jm over At. Let me write that. Cosine J. And remember from the before I had last video, I think, sines opposite over hypotenuse, cosines adjacent over hypotenuse, and tangent opposite over adjacent. Cosine J is adjacent to J, which is Jm, over the hypotenuse of this triangle, Jt. Well, J is the first angle here. Well, these triangles are similar, which means it's congruent to the first angle here. So cosine of J, since J and E are congruent to each other, the cosines from their angles are congruent to each other. So cosine of E of this triangle, for example, is ME over the hypotenuse RE. But what we're saying is that because these angles, J and E, are congruent to each other, their ratios are congruent to each other. That's why you can think of cosine J as ME over RE. And you could think of cosine E as Jm over Jt because these are equal because these angles are equal. So they're interchangeable. So what they're doing here in this question is they're giving you a letter, but they're using the ratios from the other triangle, and you got to see which one maps up correctly. I mean, we just did cosine J. It's not Rm over Re. It's Re. It's Me. So that's not true. So let's look at some of these other options. Again, I want to check all 4 choices in a true-false question. So I'll do B. Cosine R. Well, here's R, and that's also T. So basically, when I see R, I also want to think T. Just like when I see J, I want to think E. When I see T, I want to think R. When I see E, I want to think J. Again, now how do I know they're congruent? Because similar triangles have congruent angles, and E goes with J, R goes with T, M goes with M, right? They're in corresponding order every time they're listed. So cosine R, that's adjacent over hypotenuse, but we know that's not there. But what about for T? Adjacent is TM over JM. That's not over JT, not JM. That's not true. That's false. How about tangent? Tangent T we know is JM over TM, but what about tangent R? Opposite is ME over RM. That seems to be false for me too. And how about this last one? Tangent E. Well, tangent E is going to be the same thing as tangent J, and tangent is opposite over adjacent. That's TM over JM. This is true. So they're kind of forcing you to use the corresponding congruent angle from the other triangle. That's certainly tricky. All right, we're getting up to 12 minutes, but this is a real quick question, so let me do this one, and then we'll stop here. I believe this is 16, right? So here's 16. Rectangle ABC can be proven congruent to KLMN using which transformation? Again, remember, corresponding order. So what's first goes to what first? That A has to map to K, and so on. So what's going to map A to K? B to L, and so on. Well, A to K, I think the easiest is just kind of reflecting over this line. Does N go to D? N's last, D's last. B to L, second, C to M, third. So I think a reflection over this line, which is the x-axis. Reflect the y-axis, that's definitely not work. You know, rotation looks like if you were to, kind of take this triangle and pivot it down, but the problem with that is A would go to N, and we know A has to go to K, and a translation is not going to do it for us. So, choice C. All right, I'll stop this one there and pick up on 17 for the next one. See ya.